So, Rajyashree, kindly introduce yourself to the panel member.
Good evening, everyone. My name is Rajyashree Nandy, and I belong from Raniganj in West Bengal. I have completed my schooling there itself from JV Public School, Raniganj. And after completing my schooling over there, I moved to Kolkata to pursue my graduation and post graduation. I have completed my graduation in geology honors from Ashutosh College, University of Calcutta, followed by my post-graduation from Baligan Science College, University of Calcutta, with a gold medal and first class first rank, followed by which I have started my career with SRK Consulting, which is an MNC, as a staff consultant hydrogeologist, followed by which I was a young professional in Central Groundwater Board for 2.5 years. And now at present, I'm serving in Maheshwari Mining Private Limited as geologist.
Okay, that's good. So, you have an experience of both, means in the field of hydrogeology and in the mining sector, right?
Yes, sir.
Okay, so why did you given preference hydrogeologist over GSI? Is there any particular reason from your experience?
So actually, I have been working for last 2.5 years in Central Groundwater Board. So yes, definitely, I have developed an interest in groundwater. And also, as I mentioned earlier, that I had started my career with SRK Consulting as a hydrogeologist. So I think I will be able to do justice. And moreover, I was the one who actually I was responsible for studying the mod flow, that is the numerical groundwater modeling, which is a finite difference modeling on my own. So I have a bit of interest towards that domain. But nevertheless, this doesn't mean that I do not like geology, because at present I am actually working for the NMET projects for the auctionable blocks that are given by GSI. So I chose CGWB because I already have an experience in hydrogeology.
Okay, so through MMDR Amendment Act, so government
Yes.
has done any change in the process of auctioning, or it will be same?
Yes, actually, sir, through the MMDR Amendment Act that has actually come into the market very recently, there are many changes that the government has done. The first, which I would like to mention, is it has shifted 6 minerals from the first list that was actually previously preserved. I think they are lithium, I'm not sure about lithium is there, graphite is there. Earlier, what used to happen that those exploration in those minerals weren't allowed. Also, the government has actually concentrated on providing the composite license, that is giving both exploration license, exploration come mining license to the private players, because it is now much more interested in allowing the private parties to enter into this exploration field, which will also allow the exploration of the critical minerals and the deep-seated minerals.
Is there any demerit also associated with allowing private player to the mining sector more and more?
So demerits, I am not very sure of this demerits, because, sir, in an economy, if the private players, actually, I would like to state that the small companies, because I am a part of one of those budding companies right now, so I can very well understand that actually participating in this auctioning process, coming up with a block, I think, sir, it is for the development of a nation overall. It will support the economy. It will boost the economy. And not only this, sir, I would also like to mention a very beautiful example. Sir, in the auctioning process, there is a percentage which will be actually, apart from the state, whatever state will receive, apart from that, a percentage of the money will go to the NMET fund, National Mineral Exploration Trust. So what will
Yeah,
happen?
right.
What will happen, sir? This amount can be again used to provide the exploration, small exploration company, so that they can come up and take the exploration process with the fund of the government. And not only this, sir, in the auctioning process also, this district mineral fund, then the auctioning, the bidding price, the actually the royalty that will go to the government. So it is actually a benefit for the government and the private players. So I think that yes, it is beneficial for both. And I do feel that a close one step that could be taken more and more, that a very close monitoring about the whether the mining rules and regulations are followed in the mining blocks or not, the auctioning process is transparent or not. So these are the fields where the government can definitely work more, because there is an area of progress over there. I do feel this, sir.
Okay, that's so. According to you, why do the government put royalty on different minerals by different percentage? Why not it is same for all the minerals?
So actually, when the royalty rates are actually decided, IBM has Indian Bureau of Mines has already actually set up different average sale price (ASP). So, sir, the royalty is decided on that average sale price. Sir, suppose I would like to put an example as well. Sir, if we are seeing at graphite, if I'm saying, sir, graphite, when we are extracting, suppose we are mining a graphite, so it is having, suppose, a fixed carbon of less than 10%. So, for that particular graphite, per tonnage price is 1037. Then, sir, it is taking a royalty of
Okay.
rupees 25 per ton. But sir, whenever a person or a mine owner is actually beneficiating that graphite and it is taking that particular product to say more than 80%, then the price actually changes to around 47,000 per ton. So sir, in that case, the royalty then jumps to 250 rupees, something like this. So sir, royalty is very much dependent on the sale price, so that it don't become a burden on the private players also who are actually mining it out, and it can support the mine industry and the private exploration companies or the mining companies as well.
Okay, okay. So can you tell me what percentage of royalty is decided by government for lithium and RE?
Sir, I think I have read in news it was around 3% for lithium, but sir, I will have to see that again once more. I cannot recollect it right now, but
Yeah,
I will have to read that.
it's right to 3%.
Okay, thank you, sir. Thank you.
So, mm, problem of
Sir, I'm very sorry, sir. Your
contamination in
voice
your
is
state.
breaking. I'm very sorry, sir. Your voice is
Wait,
breaking. Will you please repeat? Sorry, sir. Uh, Very sorry, sir. I could not hear you, sir.
hello. Yeah,
Yes, sir.
yeah, yeah.
Yes.
Am I audible now? Yeah. So I
Yes,
was
sir.
saying
Yes, sir.
ki
You're audible.
there is an arsenic problem, arsenic contamination problem in groundwater in your state. So can you tell me what are the
Yes.
reason for that, and is the government, West Bengal government or central government has taken any step to reduce that
Sir,
contamination?
coming to the arsenic, yes, sir, definitely. Coming to the arsenic issue, sir, I would first like to tell that arsenic problem actually, if you see the state of West Bengal very thoroughly, sir, if you see that from the Malda district near the Farakka barrage, actually, the Bhagirathi River is entering. And if you see that the arsenic contamination is actually located in the blocks nearby the Bhagirathi, especially on the eastern coast of Bhagirathi River. So the arsenic in West Bengal is mainly, the origin is mainly geogenic in nature. The huge sediment influx that Bhagirathi or Ganga is actually bringing, that sediment itself contains arsenic. Now, sir, what is happening in West Bengal is not only West Bengal, also in, if I see in Bihar, Uttar Pradesh, all these areas where we have this Gangetic alluvium. So we find that this arsenic is from the geogenic deposits that have been deposited by the river itself. The arsenic contamination is present in the groundwater in the shallow aquifers mainly. Now, the reason behind this is that it is mainly dependent on the reduction oxidation reaction of this arsenic, because actually arsenic is present associated with that of the iron minerals. Arsenic is present in two forms: arsenic plus 3, that is the arsenite, and arsenic plus As plus 5, that is the arsenate. So what happens, sir, in groundwater in the shallow level, whenever this oxidation or reduction reaction takes place, so it becomes in As plus 3 format itself, and this arsenite is more poisonous and more soluble in water. So what happens? The groundwater gets contaminated. Now coming to the remedial measures by the government. So the first measure that it has taken is coming to the central government, both central government and state government. The arsenic task force has beautifully, sir, monitored all the blocks in West Bengal which are arsenic affected. I think it is around 111 or 113 blocks which are arsenic affected in West Bengal. So they have monitored that. Moreover, if we closely look at the arsenic contamination, the shallow aquifers are mostly arsenic contaminated, around at a depth of say 100 meters or 150 meters. Up till that, they are arsenic contaminated. So what happens that the government has actually suggested that the deeper aquifers can be used when the shallow aquifers are arsenic affected. The very beautiful technique actually given by Central Groundwater Board is the cement sealing technique, which actually seals the affected arsenic contaminated aquifer, the upper layer, the shallow affected arsenic contaminated aquifer, and we can directly perforate the deeper aquifers and extract the fresh groundwater. Also, in those regions where there are the deeper aquifers are very tough to explore, or it is becoming a cost is becoming an issue, conjunctive use of surface water is also recommended in many areas. In remedy to reduce, also to reduce the arsenic concentration in the groundwater, the latest technologies of artificial recharge methods, such as augmenting the surface water and then recharging it to the groundwater, so that the overall, because it will actually cause the dilution of the arsenic, so the overall concentration of the arsenic will reduce.
Okay, okay, that's good. So one last question, as you have done diploma in painting also, right?
Yes,
So
sir.
there is a famous Bharat Mata painting. So can you tell me
Okay.
the name of that person who is also belongs to West Bengal, who has made that painting?
Sir, I'm not very sure. I'm very sorry. Sir,
Okay,
I
okay.
I have to read upon this, sir. I'm very sorry.
So have you ever visited to any Paleolithic or Mesolithic caves in our country?
No, sir.
Okay, okay. Okay, thank you, Rajyashree. This is from my side. Now over to panel.
Thank you, sir. Thank you so much.
Hi Rajyashree,
Hello, sir. Good evening.
good evening. Tell me about your work in uh, what it is, SRK consultancy.
Sir, firstly, I was in SRK Consulting as a staff consultant, hydrogeologist. Sir, it was
Yeah,
at the beginning of my career, but sir, I was actually given to develop this numerical groundwater modeling, the mod flow. Sir,
numerical. Explain this thing, numerical groundwater modeling.
Sir, actually, what happens that numerical groundwater modeling, sir, this is a very powerful tool for estimating, because actually what we are doing, we are actually homogenizing the nature into certain grids, into certain models, and then we are predicting the scenario of the present and also predicting the scenario of the coming future. Sir, for example, what I can say you in brief is, suppose, sir, I can actually create a model of a particular area or a particular block. I can classify the stratas of unconfined aquifer, confined aquifer. Then, sir, what I can do, I can actually give the hydraulic conductivity values, the recharge factors, the draft factor, the rainfall will be there, whatever evapotranspiration will be there, the utility, the irrigation draft.
Okay, okay. You are telling me like you are involved in modeling.
Sir, I was involved in modeling.
You were
Yes,
involved in modeling.
yes, sir.
Okay. So, do you know the meaning of Venn diagram?
Yes, sir. Sir, I have made a lot of fence diagram during my days in Central Groundwater Board. So it is more of like the boreholes that we drill into the ground. So after that, we are actually extracting the logs from there. And so then we actually beautifully draw the panel diagrams, or we join the sections. Means it is actually a combination of the section in different direction, which will give an overall, not a 3D view, not a 3D actually, the combination of the 2D planes, and it will give a very good picture about the disposition of the aquifer.
Can you construct surfaces from that?
Surfaces. Yes,
Yeah.
sir. Yes. So if I can, suppose
You
I'll have
said la, you
forums.
said that you can't construct a 3D model from that.
No. Sir, I actually meant that fence diagram is something different from that of the 3D model.
Yeah.
3D model is the next step. So fence is
Mhm.
like joining the 2D and giving a beautiful picture about the disposition. 3D, sir, it is more like a cake model. We are just seeing the outside, but fence will give a very clear picture about the borehole to borehole if we are connecting. So this clear picture, I think fence gives a better idea about the rather than 3D. But we can definitely construct surfaces from there.
Okay. On the basis of logs, can you identify faults?
Yes, sir.
How?
Sir, on the basis of logs, if we are identifying faults, so suppose I would like to quote an example from the coal mines itself. Sir, if we see that suppose seam 5, I have taken 5 logs, and seam 5, it is present at a depth of say 100 meter in 2 logs. And in the next, it is in the next 3, suppose borehole, it is present at a level at a depth of say 150 meters from the surface. So definitely there has been a down thrown of that seam. So from there, I can also identify the faults from there, from the logs itself. Or sir, if we find a repetition of the strata, suppose seam 5 only, I am getting 2 times. I am doing the chemical analysis and I'm finding, okay, this is the seam 5. Say any marker horizon, not only seam 5, but any marker horizon, I'm getting it 2 times. Or a repetition of the entire strata. From there, sir, I can definitely identify that yes, there might be a fault nearby.
Okay, like how do you identify coal from gamma ray logs?
Gamma ray logs. Sir, I'm very sorry, sir. I'll have to read upon this.
Okay. Then like how do you identify coal then from logs? Which geophysical logs you're using to identify coal?
Uh, Sir, gamma ray is present. Whatever, sir, I know. I do not have read much about this, but as far as I can remember, sir, initially they are borehole geophysics. It is resistivity will be there. Resistivity survey will be there, and sir, some magnetic survey is also done along with the seismic.
That is okay. How do you identify coal on the basis of these surveys?
Sir, resistivity, I think there will be a change because, sir, when I'm dealing with the coal,
There will be change. I know that there will be a change.
okay.
Whether it will be the resistivity will be high or low or medium, what will be the range of the resistivity, what will be the range of gamma ray, how the porosity will be there. So
Um,
tell me these things.
Sir, I'll have to read upon this. I'm not very sure, sir. I cannot recollect.
Okay. And then about, do you know about groundwater quality maps?
Yes, sir, I know.
Okay. Like who is responsible for the preparation of this?
Groundwater quality maps.
Yeah.
Sir, in Central Groundwater Board, we used to prepare quality maps.
So in one quality map, you use a single parameter or
Yes.
multiple?
Sir, we use single parameters.
But like how a single parameter can reflect the quality of groundwater?
Sir, single parameter means when I'm plotting the arsenic, I am just plotting the quality of the arsenic map itself. Arsenic.
Yeah. That is okay. Like, but how can it be useful for us? Like, we can't determine the quality of groundwater on the basis of just arsenic, right? If the arsenic is let's say moderate, then in
Sorry, sir.
our region.
I'm actually, sir, then we will actually find another if there is any problem.
Mhm.
Suppose, sir, I just want to explain it in terms of the problems in West Bengal itself. Sir, if we are seeing the eastern side of West Bengal, there is a problem of arsenic. So arsenic groundwater quality map will be helpful in that area. Now, sir, coming to the southern coast near the South Chobbish Pargana district, near to that of Bay of Bengal, there is a problem of salinity. So in that case, sir, salinity map will actually help us to identify the problem of salinity. The contour maps.
Salinity maps, like I have never heard about this. Like for salinity maps, what physical quantity, what constituent of water do you plot?
Sir, it is electrical conductivity. EC.
Okay,
EC
it is
map we
electrical.
actually, yes, we
Done,
use for
done.
salinity.
Okay. Another thing, like you said, ki, like you identify the region and the problem that are existing there, and on the basis of that, you can use the maps. But the
Yes.
thing is, like in a localized scale, you don't know like what can be the contaminants in a local region, what are the types of rock, because like everything is not mapped, right? So in a localized region, the pollutants can be more than one. So on the basis of a single map, how you gonna define the groundwater quality?
Sir, if you are wanting in a local region where you want to show more than one pollutants, so there we can go for the spot maps, spot value maps. We can collect the data from the wells, and from there, sir, we can definitely plot different wells. We can set a barrier limit. Then we can show in different colors that these wells are contaminated in this. We can use different
Okay.
symbols for showing spot
Another
value.
question, Rajyashree. Do you ever try to combine parameters, different parameters like nitrate, sulfate, fluoride, electrical conductivity? Have you ever tried to combine all this parameter into a one thing and then plot maps on the basis of this?
Sir, combining different parameters, I haven't tried, but I think one process called the analytical hierarchical AHP, or that weighted average method is sometimes used for actually combining the different parameters and then coming up with a map which actually shows the areas where the parameters have been taken. I think this can be done. Yes, this I think this can be done.
Okay, what do you call that thing?
So that is
What is
some
this?
kind of I'm not able to recollect the entire full form. I think that is weighted, some kind of weighted average is used actually.
Yeah, that is, yeah, you are right. Like weighted average method is there. Like there are
Yes.
many methods, and the quantity that you get from those method is called as water quality index.
Yes, yes, water quality index. Yes, sir. That can be done.
Okay, so Central Groundwater Board does it right now, as of now.
Sir, Central Groundwater Board, in the yearbook, it doesn't do. But I'm not very sure. In certain special publications, I think it has done it.
Okay.
I'm not very sure, sir. I will have to see that. But in yearbook, it is not present. Groundwater
Because
yearbook.
what are the factors on which electrical conductivity depends upon?
Electrical conductivity depends upon the total dissolved solid, the TDS, that is present.
But like every solid will not contribute to the conductivity.
Sir, I think it is the presence of Cl, chloride ion mainly.
And don't you think Na will also contribute to electrical conductivity apart from Cl?
Any, sir, I will have to see this once. So as far as I can recollect right now, I've seen chloride, but sodium, sir, I will have to see.
Okay. What are the other things that CGWB does?
Sir, Central Groundwater Board has a wonderful program of national aquifer mapping, in which, sir, it has actually classified the entire country into 43 major aquifers and 14 principal aquifers, and it is carrying out the mapping process. It is carrying out, sorry, I think sir has got disconnected.
No worries, no worries. He has asked you.
Sir, will I continue?
Yes, sure.
Okay. Sir, what we do is we actually, in Central Groundwater Board, this National Aquifer Mapping, preparing of the thematic maps, then, sir, determining the disposition, the subsurface disposition of the aquifers, then, sir, carrying,
Apart from this aquifer mapping thing,
sir, pumping test, it does. Sir, then conducting various PIP programs. Then PIP programs means public interaction programs, where it actually teaches the villages. It is generally actually an awareness creating program. So it does that
and
as well. And sir, apart from this, Central Groundwater Board has also participated very actively in the Jal Shakti Abhiyan, Catch the Rain campaign. Then, sir, various artificial recharge methods in the urban areas, in the village areas as well. Sir, all these things are done by Central Groundwater Board.
Okay, Rajyashree, can you please let me know if if a single unit of rock can act both as confined aquifer and unconfined aquifer?
Yes, sir.
How?
Sir, actually, what happens is, I would again like to quote an example from West Bengal itself. So, what happens, sir, if we see at the mid portion of West Bengal, sir, we have a certain thick layer of alluvium, sir, where it is unconfined in nature because actually it is being exposed to the surface where it is receiving the direct rainfall. Now, sir, as I am coming towards the basin inward, that is, as I am moving towards the southward, what is happening? Because we are actually moving towards the basin. So, from the periphery, we are moving towards the inner side of the basin. The depth is increasing. And this unconfined layer only, with a gradual progression towards the south, it is going deeper and deeper. So, the recharge zone is actually in that area where it is unconfined. And sir, as we are progressing towards the south, the same aquifer is becoming confined in nature.
Got it, Rajyashree. Okay, another question from the same thing. Can an confined aquifer be recharged if it is not exposed to the surface?
Sir, actually, the confined aquifer is actually, we know that the groundwater movement is very slow in nature. So, sir, the confined aquifer is actually getting the water somewhere, it is being recharged, where the confined aquifer is becoming unconfined in nature.
That is okay. That is what I am saying. If
Yeah.
it is not exposed to the surface, then what are the mechanism of its recharge?
Sir, we can do, sir, induced recharge, not. Yes, induced recharge method can be one of the method in recharging the confined aquifer. And another method is, sir, this artificial recharge technique can be also used.
Not artificial, not artificial.
So then
In general,
induced,
the first thing is that like we will not spend our money in recharging confined aquifer
okay,
if we are using artificial techniques, right? So,
okay,
remove the artificial thing. Any other natural processes by which this can be recharged?
natural processes. Sir, is induced recharge a method? I am not very sure about this.
Okay. Okay, another question.
Yes, sir.
Uh, you are having two aquifers. One is confined and another is unconfined. Confined is at the bottom, unconfined is at the top.
Yes, sir.
And below the unconfining layer, unconfined aquifer, there is an unconfining layer. Okay, there is a confining layer, sorry. And the confining layer is not totally unconfining, it is a bit leaky. Okay, and the hydraulic head at the unconfined aquifer is 2 and at the bottom it is 3. So what will be the direction of water flow?
Sir, I'm very sorry, I couldn't get the question. So
You
will
are
you
having
please
two
repeat?
aquifers.
Okay,
The first one is unconfined, which is at the top. Second
okay,
one is confined, which is at the bottom. At the
okay.
top, you are having a hydraulic head of 2, and at the bottom, you are having a hydraulic head of 3. In which direction the water will flow?
Uh, First is having a hydraulic head of 2. So generally the water flows in a direction of higher head to lower head. But sir, when we are actually dealing with the unconfined aquifer, we are talking about the water table. And whenever we are dealing with the unconfined aquifer, we are actually dealing with a piezometric surface. So, sir, as far as I can remember, sir, whenever we are actually deciding the flow, that where the hydraulic gradient will be, sir, I think we need to separate those two, and then we can draw the contours and we can draw the flow lines accordingly. But if in a general, it is always from the high head to the low head direction.
What is the difference between piezometric head and hydraulic head? Do you think there is really a difference between the two? If you are talking about like the physical parameters being involved to calculate these two things,
Sir, hydraulic head means you are telling about
not hydraulic head, sorry, water table and piezometric surface.
Yes, sir. There is a difference because the water table, wherever we are actually talking about water table, so we are actually restricting ourselves to the concept of this unconfined aquifer. So we are actually drilling inside the ground. We are entering the water. We are just
That is
entering the
that
first
is totally okay. I am asking like, is there any physical difference between the two?
physical
The thing
difference.
the thing that they are representing, what are they represent? What are they trying to represent? What is water table representing? What is piezometric surface is representing? Is there any difference between the thing that they are representing?
Sir, they represent a surface where the hydraulic pressure becomes equals to the atmospheric pressure.
That is what I am asking. Is there any
Yes.
difference between
No, sir.
what
Here
it is?
also the same thing happens. In piezometric surface also the same thing happens.
So then, like, then tell me the direction of water flow.
Sir, it will be from a high head to a low head towards the hydraulic gradient, I think.
That is from bottom to top.
Okay, bottom to top.
Okay.
Yeah.
Okay. Another thing, like, which of the following material is having the highest porosity? Clay, silt, or sand?
So sand. Sorry, very sorry, clay. Clay is having the highest porosity.
Okay. Again, like, which material is having the highest porosity? Sandstone or clay stone or silt stone?
Sandstone, I think.
Why?
Sir, because I think it is somewhat related to that of sir, compaction. I'm not very sure. I'll have to see this, but I think sandstone will have the highest porosity. I will have to read
Okay.
upon this, sir. I will have to see this. But clay is having the highest porosity. But what about when it becomes consolidated? I have to, sir, see this once.
Okay. Another question, like simple one. Why the specific yield of clay is lower? Like it is like we call na ki it is like impermeable. It doesn't gives out water. Why the specific yield of clay thing is lower as compared to sandstone?
Yes, sir. Clay has a lower specific yield because so that's why it is aquiclude. The clay layer generally
Like
is not able to.
why it is an aquiclude? Why it is having a lower specific yield?
So it does not contain permeability. Interconnected pores are not there. For a material to have a good specific yield, the interconnected pores must be present. It should be
Okay.
permeable as well.
Let us say if there are interconnected pores,
Mm.
then let us say that the clay is unconsolidated. In case the clay is unconsolidated, there will be interconnected pores. So what
No,
will
sir.
happen then?
So clay is clay. Clay. The term clay is actually because of the unconsolidated sediment itself. Clay is
Ah,
actually the grain
yeah,
size.
right,
Sediments are
right.
unconsolidated. That's why we are calling it clay. If the
That's
sediment
why
becomes
that's why you should answer that like why it is having low permeability even if it is not consolidated.
sorry, sir, I cannot get your question. Uh,
See, clay is not consolidated.
yes,
Then why it is losing its permeability?
because the pores are not interconnected in nature. Because clay has a very high porosity, but since the interconnected pores are not present, it does not have any permeability. Therefore, when it can hold water, but it cannot yield water. Therefore, the aquiclude, sir, whenever I was actually previously speaking about the cement sealing techniques, so
Do you
whenever
know the do you think there is any role of capillary pressure or surface tension in making clay permeable apart from this interconnected thing?
so surface tension and capillary in making clay permeable,
Impermeable.
impermeable. Sir, in clay minerals, I know that along the surface, that is actually we actually consider that as a part of the ineffective porosity, where the water is held as adhesion to the clay mineral, actually clay particles. So that is the water that does not actually participate in the porosity. So That is one water that is held by clay on the surface itself. So that I know.
Not very clear, Rajyashree.
I'm very sorry, sir. I'll have to read upon this then.
Another thing, like you have four of two sizes. One is small, one is large.
So
Okay.
sorry, pores or
Yeah, last question from my side.
okay,
You have two pores, like one is of smaller size, one is of larger size.
okay.
Okay. From which of one of them you can drain water faster?
So the larger size pore.
Why is it so?
So because if you're talking about the draining of the water, draining of the water. So is it if it is related to the capillary action, then it is the small size pore. But if it is related to the action under gravity, I think the large size pores.
You are not supposed to ask me question.
Sir, very sorry. I'll have to respond this. Sir, I'm just telling. If it is capillary action, then it is definitely small size pores. But for I think under the action of gravity, is if the water is draining out, then it is the large size pores. But definitely,
Uh-huh.
I'll have to see this.
Okay, please have a look into it. Okay, Rajyashree, this much from my side.
Thank you so much, sir. Thank you.
Rosny ma'am, I guess you can continue. Devasi sir is not there.
Hello, am I audible to you?
Yes, madam, you are audible to me.
Okay. Okay. So please tell me what is plumose structure?
Plumose structure.
Yes.
Madam, I cannot recollect it right now. I'm very sorry.
Okay. And what do you mean by tectonites?
Madam, tectonites are the deformed rocks. Yes, as far as I can recollect right now, they are the deformed rocks which are formed. That LS tectonites, S tectonites, I can recollect just that.
Okay. Okay. Right.
Yes,
So, okay, next question. How does discrete granulation cleavage form?
discrete granulation cleavage form. Okay.
Yes.
Madam, I think, madam, granulation cleavage is actually forms under, means, ma'am, the first part is when there is a bedding under the compression stress. Then, madam, then forms the cystosity planes in an different direction when the stress is applied in a different direction. Then forms the cystosity planes, and after that, again due to the reversal of this pressure that happens, then forms the granulation cleavages over there. So I think when it is talking about the discrete granulation cleavage, there will be certain space between the cleavage, the lithodomain or the spacing, something, madam, related to that. I cannot recollect it.
Okay. Okay,
Hmm.
no issue. So, what is the composition of ropy lava and blocky lava?
The composition of ropy lava and blocky lava. Madam,
Right.
ropy lava is a lava that will actually flow for a very large distance, long distances, and then there will be crinkles on its surfaces. So if it is flowing, that means its viscosity is less. So it will be more of a basic kind of lava. But whenever we are talking about the blocky lava, it is not flowing at a very larger distance. The viscosity will be high. So it will be more of an acidic lava.
All right. Okay. So, what is Pompili rule?
Pompili's rule.
Yes.
Madam, Pompili's rule, as far as I can remember, it states maybe whatever we see in the small structure, in a small scale, the same is actually repeated on a larger scale.
Right. 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 Okay. So, what is harmonic and disharmonic rock? Sorry, fold.
Folds. Madam,
Yes.
harmonic folds are actually having a continuity pattern with that of the original structure and they form a rhythm. But whereas this disharmonic folds, their pattern is very unpredictable, and they do not maintain any rhythm or the continuity or parallelism with that of the enclosing or the original folded structure.
Okay. You know what is living fossil?
Living fossil. Yes, madam. The actually fossil. Whenever we are using this term fossil, we generally define something that is of prehistoric origin, organic in nature, and preserved naturally. So, certain suppose if I'm taking say brachiopod, so a fossil that has actually originated. Sorry, I think that has actually originated way before, but a species or a genera of it is still continuing till date. So that is a living fossil.
No, not exactly. Living fossil is something different. Okay.
Okay,
So,
okay. I'll read upon it.
okay.
Definitely.
So, you know, ammonite is extinct during which mass extinction?
It is, madam, during the KT mass extinction, I think. Triassic,
Right.
Jurassic, Cretaceous. Yes, KT mass
Right.
extinction.
And which is the warmest period of on the Earth's surface?
So, madam, it's Cretaceous.
Okay. Name any planktonic forums which is known as the monsoon proxy.
Madam, very sorry. I'll have to read upon that.
Okay. Okay. Most primitive trilobite.
Calamine, I'm not sure, madam.
Okay. Okay. No issue. What is back peering and back reading?
Madam, back bearing is when we are actually taking our position with respect to the, suppose we are getting a mountain in front of us. So we are actually measuring our position with respect to an object that is present in front of us. So that is our
Okay.
back bearing that I know. But back reading, madam, I'm not very sure about that.
Okay. Okay. So, what is Hoodo-Hawkins rule?
Sorry.
What is Hoodo-Hawkins rule?
Udo Harkin's rule. Madam, it is somewhat related to the element concentration, and it is somewhat related to the element even numbers and the odd numbers. So the elements that are having atomic number as even, they are maybe concentrated more as compared to that of the elements that are having odd number elements or something like this.